Now, there are some interesting properties of a normal distribution curve that you need to know. Now, of course, the curve is bell-shaped. Now, it's also symmetric about the vertical line x equals to mu, the mean. Okay, everything on the left and everything on the right of this line is symmetric. Now, the curve will also approach the x-axis asymptotically, meaning the line y equals to 0 is actually an asymptote. Okay, you look at the tail ends here, the curve will approach the line y equals to 0 as it approaches minus infinity to infinity. Okay, your y will approach 0 plus. Okay. Now, the mean, the medium, and the mode of a normal distribution is actually the same. Okay, if you recall, what is the mean? The mean is actually, if you have a lot of data points, you add up all those data points and you just divide by the total number. What about the medium? The medium is when you arrange the data points from the lowest to the highest, the value in the middle is the median. What about the mode? The mode is the data point that occurs the most frequently. So for a normal distribution, it has got this special property that the mean, the medium, and the mode, they are all mu. Now, the mean, mu, is an indication of the central tendency of the data. Now what this means is mu, right, is some kind of indicator to tell people what the data is likely to be. Okay, so different values of mu indicate different locations of the mean. Now the variance, on the other hand, is an indication of the dispersion, or rather the spread of the data. The smaller the sigma square, the smaller the dispersion, and the narrower the bell shape. Okay, now note that sigma square, okay, can never be negative. It's always the square of a number. Now if you look at the graphs that you see on the same page, now the graph on the left shows you 3 bell curves. Now the 3 bell curves, right, they all have the same mean. Okay, you can see that they all have the same mean, but they have different variances. Now the one that has got the largest variance is the green bell curve. See how far spread the data values are? Okay. Now the one that has got the smallest variance is the blue bell curve. Okay, easy to see, right? Then if you look at the graph on the right, you see 3 bell curves. There are 3 identical bell curves. Now they all have the same variance. Okay, the spread of data is the same. Okay, it has got the same shape, but the means are all different. Okay, again, it's quite easy to see. The mean for all 3 bell curves are all different. Now before we look at some questions, there are some more properties, and there is this very special normal distribution that I want to talk about. Now this normal distribution, right, is actually the special case when your mu, okay, happens to be 0 and your sigma square happens to be 1. Okay, now this normal distribution is what we call the standard normal distribution. Now it's a standard, or rather it's a normal distribution that we use quite often. Okay, and then because we use it so often, okay, there's a special label given to this normal distribution. We call this the Z. Okay, Z is a normal distribution that has got mean 0 and 1. Okay. Now the actual shape and location of the bell-shaped curve, or rather of any bell-shaped curve, depends on the values of mu and sigma. So if you have, for example, the standard normal curve, then the standard normal curve will be centered about the origin. Okay, the x equals to 0. Now moving on, now the next property, right, is actually something really important. Now if I want to find the probability between A and B, okay, I want probability x between A and B. Now this is defined to be the area under the density curve between A and B. Now if you want to find area, remember what you need to do. You have to integrate. Okay, you have to integrate your density equation of the density curve, okay, from A to B. But if you recall, now this is a complicated looking curve, or rather equation, but the good thing is you can actually use your GC. Okay, your GC can let you evaluate this probability very quickly. Now Another property to note, once you know that area on the graph is actually the probability, the total area must be 1. Okay. Now, property 9, right, is something really interesting. Now, it says that actually in any normal distribution, now if I were to mark out the mean, okay, if I were to mark out the mean in any normal distribution, and I say that, oh, okay, let's subtract a mu from the mean and add a mu to the mean, and I look at the area under the curve that is bounded by the line x equals to mu minus sigma and x equals to mu plus sigma, then I realize that the area under this curve, right, is actually 68% of the total area under the curve. And now what this also means is the probability of x between mu minus sigma and mu plus sigma is actually 0.68. Now similarly, if I again mark out mu and I mark out mu plus 2 sigma and mu minus 2 sigma, now the total area under the graph is actually 95% of the total area, which again, in other words, just means that the probability of your x between mu minus 2 sigma and mu plus 2 sigma is 0.95. Now the last case, okay, is when again I mark out mu and I mark out mu minus 3 sigma and mu plus 3 sigma. The area under the curve, alright, in this case is 99.7%, okay, which again, in other words, is 0.997, okay, of the probability of getting x between mu minus 3 sigma and mu plus 3 sigma.